What if your eyes aren't lying, but your brain is? You stare at two lines that look completely different in length, yet when you measure them, they're identical. You see a still image that somehow moves. You swear two colors aren't the same until someone places them side by side and proves you wrong. It feels unsettling, almost personal. Because if your brain can be fooled by something so simple, what else might it be getting wrong? Are optical illusions just visual tricks? Or are they revealing something deeper about how reality itself is constructed inside your mind? Today, we're not just looking at illusions. We're looking at the machinery behind perception itself. Welcome back to Simple Things Why and How, where we explore the hidden processes behind everyday experiences. Optical illusions aren't magic. They're not glitches in your eyesight. In fact, your eyes are doing exactly what they're supposed to do. The real mystery begins after the light enters your eyes. In the silent, lightning-fast decisions your brain makes every second. Because here's the truth most people don't realize. You don't see the world directly. You see your brain's interpretation of it. When light reflects off objects around you, it enters your eyes and hits the retina, where specialized cells convert it into electrical signals. Those signals travel through the optic nerve to the visual cortex at the back of your brain. But here's the surprising part. By the time that information arrives, it's incomplete. Your brain isn't receiving a fully labeled, perfectly detailed picture of reality. It's receiving fragments, edges, contrast, color differences, motion cues. So what does it do? It predicts. Your brain constantly uses past experiences, patterns, and assumptions to fill in the gaps. It builds a best guess of what's out there, and most of the time, that guess is incredibly accurate. But optical illusions exploit those guesses. They take advantage of the shortcuts your brain relies on to make sense of the world quickly. Imagine our ancestors standing in tall grass. If something moved slightly in the distance, it was safer to assume predator than wind. The brain evolved to prioritize speed over perfect accuracy. It developed shortcuts, mental rules, to interpret depth, size, shadow, and motion almost instantly. For example, your brain assumes that light usually comes from above, because for most of human history, the sun was the primary light source. So when an image reverses shadows in a certain way, your brain may interpret a bump as a dent, or vice versa. It's not failing. It's following its programming. Consider the classic illusion where two identical lines appear different in length because of arrow-like shapes at their ends. Your brain interprets those angles as perspective cues, like the corners of a room or edges of buildings. It assumes one line is farther away. And if something is farther away but appears the same size on your retina, your brain concludes it must actually be larger. So it corrects the size in your perception. The lines haven't changed. Your brain's interpretation has. Optical illusions often manipulate context, and context is everything to perception. Color illusions are even more fascinating. Your brain constantly adjusts for lighting conditions. If you walk from bright sunlight into a dim room, objects don't suddenly look dramatically different in color. Your brain compensates automatically, but when an image mimics unusual lighting conditions, your brain may overcorrect. That's why the same shade can appear completely different depending on surrounding colors or shadows. Your brain isn't just seeing color. It's estimating what color should be under assumed lighting. And sometimes, that estimation is wrong. Then there are illusions where a still image appears to move. Your brain is extremely sensitive to contrast and small changes in brightness. Certain repeating patterns and gradients trigger motion-sensitive neurons in your visual cortex. Even though nothing is physically moving, your brain detects patterns that resemble motion signals it has learned to associate with movement. So you see motion, not because it's there, but because your brain expects it. Here's what makes optical illusions so powerful. They reveal that perception is not passive. You are not a camera. A camera records light exactly as it arrives. Your brain reconstructs, edits, predicts, and sometimes even invents details to create a coherent story. Reality, as you experience it, is a collaboration between the outside world and your internal expectations. Optical illusions simply expose the seams in that collaboration. They show you the moment your brain's shortcut doesn't perfectly match reality. And that can feel unsettling, but it's also extraordinary. Because it means your brain is not just observing the world, it's actively building it. The next time you see an optical illusion, don't think of it as your brain being fooled. Think of it as catching your brain in the act of doing what it does best: predicting, interpreting, and protecting you with incredible speed. Without those shortcuts, you wouldn't recognize faces instantly. You wouldn't judge distances accurately. You wouldn't react quickly to danger. Illusions aren't flaws. They're evidence of a system so advanced that it occasionally reveals its own inner workings. And that's not weakness. That's brilliance. If this made you look at your own perception a little differently, give this video a like so more curious minds can discover it. Share it with someone who loves questioning reality. And subscribe to Simple Things, Why and How, because the world around you is only half the story. The other half is happening inside your mind. Until next time, stay curious. And remember, what you see isn't just out there, it's also in here.